In a redox reaction, there's typically two substances. One substance loses electrons, the other substance gains electrons, and those two substances are usually metals. And what happens is electrons are exchanged or transferred between two metals. And this can be predicted using a metal activity series. So we can predict reactions when two metals are in the reactants. This can be used to predict redox. It can also be used to predict replacement. So we're going to look at replacement reactions. So this is the metal activity series used to predict metals when they are in a reaction, when you have two metals. And basically it asks when you have the two metals, will one metal be more reactive than the other metal? Okay, so the way this is listed is top to bottom. At the top, these are the most reactive metals: lithium, potassium, calcium, sodium. These are all family 1A and 2A. So these are at the bottom the least reactive or the lowest activity. Copper, silver, mercury, and gold. These are also called precious metals, and that's because of this having to do with the activity, is that these metals can be found in nature in their unreacted state. Just copper as an element instead of copper the ion, or silver the element instead of silver the ion. And this is compared to these that are the high activity. These are very reactive, and so lithium, potassium, calcium, and sodium are not commonly found in nature in their unreacted state. These are already present as ions, usually in ionic compounds like sodium in sodium chloride. Okay, so these are metals that are usually already ions in ionic compounds where it's a metal plus a nonmetal. This reactivity series also includes H2. Now, H2 is listed as hydrogen gas, and that's because hydrogen can act like a metal. Hydrogen is in family 1A, the alkali metals, and so hydrogen can act like a metal in that it can lose electrons and form the hydrogen cation, H+. So the way this is, not all the metals on the activity series are listed, so this is just simplified for Chem 9. But the activity is related to electrons, the number of valence electrons. It's also related to the sizes of the atoms. And it's also related to electronegativity. So electronegativity is the ability of an atom to hold on to electrons, to pull electrons in bonds that it would form with other atoms. And so these most reactive metals in the activity series have a low number of valence electrons and also a high electronegativity. They have a high ability to attract electrons from other atoms. And so these low reactive, the least reactive metals on the activity series, these have almost all their valence electrons. And this is these are actually in the D, the transition metals. And so that includes a different type of structure internally, but these are called the precious metals, and they're normally found in nature in their elemental state. So how this activity series is used is by looking at it from top to bottom, and the higher the metal, the more reactive it will be. So it doesn't have to be all the way at the top. If one metal is higher than another metal, it will replace the lower, less reactive metal. So for instance, if you have two metals in a reaction like lithium and gold, lithium will replace the gold because it's higher up. But if you have two just right next to each other, lithium and potassium, lithium is higher than potassium, and so lithium will replace the potassium in a replacement reaction. So they can be right next to each other, or they can be far apart from each other on this chart. The higher metal will replace the lower metal, and there will be a replacement reaction that occurs. So we use this to predict if there will be a replacement when there are two metals in the reactants.